This is a solution to question 7 on the S1 paper from January 2013. It's about Spearman's rank correlation coefficient. We've got lots of competitors, and every time they're judged by their two judges, their judges are always out by 1. Well, the formula for the Spearman's rank correlation coefficient is 1 minus 6 sigma d squared over n into n squared minus 1. Well, that d is the difference. Now what's happening here is the difference is 1 on every single time. So sigma d squared is going to be n lots of 1. In other words, it's going to be n. So the formula becomes 1 minus 6 times by n over n into n squared minus 1. And we're told that the value of this is 63 over 65. Well, the fraction on the right, you can cancel an n at this point, like that. Then what I would do is I would keep my 1 here, move the 63 over 65 across where it becomes a negative, and move what's left of this fraction here, which is a 6 over n squared minus 1, to the left, where it's a negative over here. It'll be a right over here. Now I've got 6 over n squared minus 1 equals 2 over 65. Because what I want is on the bottom, I'd flip both fractions over. Just turn them both over. As long as you do the same thing to both sides, that's fine. Then I've moved this 6, it's a dividing 6 here. I'll take that up to the other side where it's a timesing by 6. And you work out the n squared minus 1, if you do this, is, I think it's 195. I'll just check that one a minute. 65 times by 6 divided by 2, sorry, 130. Let me just check I've got that right. 65 times by 6 divided by 2, so 195. Yeah, 195. So n squared, well, I need to move that minus 1 the other side, it becomes a plus 1. It's 196, and square root that to get n, and you get n is 14. So we now know the value of n, it's 14. There were 14 competitors that were being judged. Now, in part 2 of the question, they talk about a bivariate distribution. Bivariate just means that there are x and y values to your data. So it's not like a normal distribution or a binomial distribution or anything like that where you're looking for a special name distribution. Bivariate just means it's two pieces of data and there's a relationship between them. So you might be finding a correlation coefficient or a regression equation, something like that. So in part A, they're asking you to say whether R equals 1 implies that RS equals 1. Where this R here is the product moment correlation coefficient, and this RS over here is Spearman's rank correlation coefficient. And is this statement true or false? And you've got to explain why. If the product moment correlation coefficient is 1, that means you have a line and all your points are exactly on the line. There's no deviation away from that line whatsoever. Well, if that's the case, Spearman's rank correlation coefficient will also be 1. It will be the same, because each person, as one value gets bigger in the x direction, also gets bigger in the y direction. It means basically the ranks will tie up. So that is true. It's true because all the points are on a straight line. All points are on a straight line. Then the next part of the question, it's asking you something similar. It's saying if R does not equal 1, does that imply that RS does not equal 1? So that's saying if the product moment correlation coefficient isn't 1, does that imply that Spearman's rank correlation coefficient also isn't 1? And the answer is no. These 3 points here, which clearly aren't in a straight line, you would not have R equals 1. Product moment correlation coefficient is not 1. But for the Spearman's rank one, it would be. As long as for Spearman's rank, to get from one point to the next, you go right and up, then the ranks are agreeing. This rank is bigger than this rank in the X direction and the Y direction. This rank is bigger than that rank in that direction and that direction. So as long as you were going up, it's almost like a set of stairs. If you sort of start with one along and up, it doesn't matter what size these stairs are, all of these points here, regardless of whether they're on a straight line or not, they would still give you a perfect Spearman's rank correlation coefficient. So for this question, the answer is no, it is not true. And what you would really need to do is a diagram like this and show that even though the points are not on a straight lines, their ranks are still increasing equally. So that is how you would answer that question, that one is not true.